All right, thanks everyone. So as Christine and Sherelle said, I'm Justin Filiberto. I am a senior staff scientist at the LPI. I study volcanoes throughout the solar system. I study a lot of volcanoes on Mars, Venus. I've worked on the Earth. Before I start, I'll tell you how I got into this. When I was a geology student at the university, and one of my first experiences in the field and going out and seeing rocks was a volcano in Mexico City called Popocatépetl. And as we're pulling up on the volcano, the ground shakes and we hear a boom and we look up and the volcano exploded. So that was what got me into studying volcanoes, was literally being on an active volcano and sort of being welcomed by it exploding. So obviously, we've never set foot on Venus or Mars, but we can still study them and figure out how similar or different than they are than what we know about the Earth. And this is my favorite picture of Venus because you can't actually really see it. And I know, and I apologize, I can't remember who said this. Tiffany said, one of the cool things about Venus is how thick the atmosphere is and how corrosive or caustic, how hot it is. And so when you look at Venus, this is what you see. You see the clouds, you don't see the surface. So you say, well, if the clouds are this thick, how do we sort of see below it? And how do we understand anything about the surface and anything about the volcanoes, whether or not it even has volcanoes? That didn't work. There we go. So this is our list of the missions that we've sent to Venus. And if I showed you this list for Mars or the moon, you wouldn't even be able to read it. The type would be so small. We've had very few missions to Venus, but we've had enough that we can understand something. And the three in red, Venera and Vega, were sent in the 60s and then again in the 80s by the Soviets, and they actually landed on the surface of Venus and actually measured some of the rocks. And because, as Tiffany pointed out, the atmosphere is so hot, they only lasted about an hour before the instruments melted. Now we think about Mars, we have Curiosity going on a rover, roving around for 7 years. Opportunity lasted for over 10 years, and yet on Venus it can only be about an hour. So the other way to investigate for Venus, where we can actually send things longer, is we can go into orbit and look through those clouds. And so that's what I'm going to be talking about today, is some of the data and how we can see the volcanoes through the clouds in orbit around Venus. The first thing to look at is topography. Where are the high areas, where are the low areas? And so this is topography. I don't know if you can see my cursor, but the red areas are the mountaintops. So if you look all the way at the top, we've got these giant, what's an ancient crust. And then we've got some in the middle where we've got larger volcanoes. It says Venera 9, that's where the Venera 9 lander landed, Venera 10. And then all the blue, that's not actually water, that's the lowlands. That's where lava flows have come in and resurfaced, and it's sort of the flat plains. And then if you look at the bottom, there are these white strips. That's missing data. So even though we've sent these missions, there's still a lot of Venus that we don't know about because we just don't have coverage and imaging. As I said, if you go play on Google Mars or Google the Moon, you can see the entire surface of those planetary bodies. But for Venus, we don't have full coverage, but we still see cool features. And some of the things I'm going to be talking about are in this region where we've got these volcanoes. So one of my favorite volcanoes is called Sapus Mons, Mons being mountain. And you can see here, this is, instead of an image like we would take on the Earth, this is radar. Radar is cool because it can take an image, but it can get through those clouds. If we just took a picture, all we'd see is clouds. But if we take a radar image, we can get through those clouds. And so the colors here are about the properties of the volcano and not necessarily the actual colors. But what we see here is a volcano. It's about 400 kilometers across. It's 1.5 kilometers tall, and it has very low slopes, which means if you were standing at the bottom of the volcano and trying to climb up it, it would be like climbing up Hawaii. And so I have a picture of Hawaii down here and some nice runny lava flows on Hawaii. These are not on Venus, but these are the same things that we're seeing at Sapis Mons. And so it's a very Hawaiian style volcano. Lots of lava flows, all of these bright spots you can see here. These are all lava flows that poured out of the center of the volcano. Sorry, my screen is not advancing. There we go. Okay, another really cool volcano is called Mount Mons. Again, Mons being mountain. And so the one on the left up here, this is what the Jet Propulsion Lab put out as their press release when we started imaging Mount Mons. And if you look at this, you can say that looks nothing like Hawaii. That looks like I'm hiking in Mount St. Helens, or the first volcano I was ever on, Popocatépetl in Mexico. Very steep slopes. Well, it's because the image has been stretched vertically. And if you actually put it back to what it looks like this. That looks just like Hawaii. You could easily start sort of hiking, and it would be a hike just like you were hiking up the Big Island of Hawaii, or going up Iceland, or another volcano like that. These are called basaltic shield volcanoes, and they're formed by lava flow after lava flow. And actually in this image, you can even see one of the ancient lava flows coming out here, and you can see little fingers here. The other cool thing about Mount Mons is this lava flow is so bright in radar, and that's telling us that it's fresh lava. And so then this begs the question, how young are these lava flows? If we go to Mars, Olympus Mons started forming billions of years ago. Most of it formed back then. If we go to a moon called Io, we've seen evidence for active volcanism. If we look up at the moon, most of those lava flows are ancient too. And the question here, this looks relatively fresh. These look like young lava flows, but how young is young? And to a geologist, young is different than what we think about in everyday terms. So in order to look at how young these flows are, we have to figure out how fresh they are, or how much they've corroded. So we think about when we put, living in Houston, we think about how hot and humid it is out here. If you put out something with metal in it, it starts rusting. Well, on Venus, the surface is so hot and the atmosphere is so thick that anything on the surface starts rusting, starts corroding. And so if we see a fresh basalt, it tells us it's young, but how young is young? And so what we do is we have a different orbiter. This is the Venus Express orbiter from the European Space Agency, and it can look at the surface using light that's been reflected off the surface. And we can use that to tell how fresh the lava is, and then we can use that to figure out how young or old it is. And so this is another volcano. This is called Iden Mons. And you can see here, again, it looks just like Hawaii, low, flat slopes, like the other volcanoes, so very consistent with all of the others. And now you can see what's called emissivity. And this is how light is reflecting off the surface. The bright spots are the fresh lava. And so if we look, and now the top area is topography, the bottom area, so this is the first image we looked at, the bottom is how this light is reflecting. And you can see down here in IMDAR, that very, very, very dark red area. That tells us that this is an incredibly fresh basalt. And so what we study about this is how quickly this reacts with the atmosphere to change. And what this is telling us is that that lava flow is only a few years old, not tens of years or hundreds of years or thousands of years, but only a few years old, that lava flow right here. And so that tells us, like the Earth, like that volcano I was on many years ago, this lava flow has just come out of this volcano, and Venus, like the Earth, is volcanically active. So that's really cool. These are the Hawaiian style volcanoes. But do we have evidence for other types of volcanoes? And the answer is yes. There are some really weird volcanoes on Venus called pancake domes. I know it's almost lunchtime, but I just had breakfast. And these look just like the pancakes I had. They're flat, they've got very steep slopes, and they're round. That's not like any volcano that we can think of on the Earth. And so Yep, so these are single flows. They're steep sides. They're about 1 kilometer in height, and they're very different types of volcanoes. Now I'm going to kick this over to Christine now because she's going to do a demonstration of how pancake domes could have formed. If I can.
So what I'm going to do is I'm going to share a demo, and at the beginning I'll tell you what I'm doing, but Justin's going to chime in throughout and tell you a little bit about what this is and how it's relating to volcanoes on Venus. So the demonstration here is called elephant toothpaste. How many of you have seen or heard of elephant toothpaste? I see some hands up. I'm also watching the chat box, so so feel free to chat in the chat box, and yeah. So you have how many of you have done it? Never. It's elephant toothpaste is pretty cool. You do have to be careful. I'm wearing gloves because I'm going to be using something called hydrogen peroxide, and I'm using an extra strength hydrogen peroxide. And Christian, yes, it can be hot at first. You're going to see it getting hot at the beginning. And the hydrogen peroxide and the heat are the two things that are dangerous. So if you do this, you're going to want to wear goggles just for safety, and you're going to want to wear gloves, and your parents need to help. And we can send you a website where there's directions. So we're going to do this now, and we're going to use it as a model for pancake domes. So the first thing I'm going to do, I have a bottle here, and in this bottle, I'm putting it in a cup so it doesn't fall over. I've got some cardboard here around it that's going to be the support structure for the pancake dome. And the first thing I'm going to do is I'm using a small bottle, so I've got 1/4 cup of hydrogen peroxide. I know it looks like water, but it's hydrogen peroxide. So this is the stuff that can burn your skin a little bit if you touch it. So this is the main dangerous thing. Okay, and I've put that 1/4 cup of hydrogen peroxide in it. I'm going to add some drops of food coloring to make it easy to see. And we've decided we're going to do red and blue makes purple. So I'm going to do 5 drops of red. 1, 2, 3, 4, 5, and we're going to do 5 drops of blue. So 1, 2, 3, 4, 5. And then the other thing we're supposed to add, if this was a big bottle and I used 1/2 cup of hydrogen peroxide, I'm supposed to use a tablespoon of dishwashing liquid, but I'm going to just do 1/2 of one because we've cut our whole recipe in half pretty much here. So I'm going to add some of that to it. And now that that's in there, I'm going to swish it around a little bit so it all mixes together. You can see the food coloring in there and the hydrogen peroxide. And we're going to let it start to mix there. And then separately, we've got some hot water. And I don't need a whole lot of hot water. I've heated up this water in the microwave. I'm going to put it in a bowl here that we're going to add in a little bit to the bottle. So in this bowl, I'm going to put, for starters, I've got some yeast here. I've got 1/2 tablespoon of yeast. Normally the recipe calls for a full tablespoon, but I'm reducing everything by 1/2. And I am going to add, let me see how many tablespoons of water. I need to add, how much water? Not a lot. I need to add just a couple of tablespoons, a tablespoon or 2 of water. So there's 1 tablespoon of hot water, and I'm going to add 2 tablespoons of hot water. And then I'm going to mix it up in here in my bowl. We want it to get nice and mushy. We want it to turn into the consistency of oatmeal or something. So, and unfortunately, it's sticking to my spoon. I'm going to use another spoon here to help me get it off of the spoon and help it to mix together. And what's happening is that yeast is starting to react to the hot water. And break down a little bit. It's just about ready. Okay, so we have our ingredients. We have the hydrogen peroxide and the dishwashing liquid in the bottle. And then on the outside of the bottle now, we are going to add the yeast and water. But before we add the yeast and water, I need my, I need to add the funnel so I can pour it in. This is one of those Where's Waldo moments. I don't see my funnel. There it is. I'm going to rinse out my funnel because it still has hydrogen peroxide in it, and we don't want to do the reaction too early. So I'm rinsing out the funnel. Here's my funnel. And here's the yeast and water. Everybody ready? Because this is our big moment. And we're pouring it in, and we're going to take that out, and here we go. And there we have it. Let's make sure you can see it all right here. We have, and it is hot. The bottle itself, I'm holding the bottle with my gloves. The bottle has become hot, and you might see a tiny bit of steam rising from it. So the reaction is hot. Would you say these slopes are really steep or not steep at all? How would you guys describe these slopes? If this was a volcano. It is foamy. It was hot, but it's cooling off now. Not too sure. Sort of a little bit steep on the slides and then kind of flat. Does that make sense? Steep at the very edges, and then after the very edges, it's flat on top? Justin, your turn.
So that looks just like our pancake domes, where we've got sort of a flat pancake with relatively steep sides and a relatively flat surface. So, and now we've got a crater in the center of it too. So the question is, how did this form? Well, you can see, if you think about lava flowing at Hawaii, it flows out and sort of down the slopes. Here, the magma came up and then sort of spread out, but didn't move very far. It's very sticky magma. And so this is how pancake domes form, is it's very sticky magma. It comes up, it sort of spreads out a little bit, but it doesn't really go far. It's not very runny, just like, unlike Hawaii, this is sort of sticky magma. And so that gives us our nice pancake dome. And in this case, it's sort of purplish blue.
Awesome. So this is time for our Q&A. We are almost done. This is time for people to start asking questions. I'm going to stop share. I'm going to return the host to Sherelle. And while I'm doing that, folks, why don't you go ahead and start entering your questions for Dr. Filiberto in the chat box, or you can also ask them on your microphone.
Hi, Becky. Yes, it does look like it was smashed. That sort of was exactly what pancake domes look like. It looks like someone sat or flattened it.
I wanted to speak about your story that you had in the introduction. Justin, you said that you guys you heard a loud boom as if you were standing on an active volcano. Were there any signs or like a warning or anything prior to, did they know it was happening that day, or were they, monitoring it? Or can you tell us a little bit more about that?
Yeah, so when I was up on Popo, it was heavily monitored. It was on and off active eruptions, so we knew there was a chance that it could erupt while we were up there. The area we were at was closed to tourists. We were with scientists, and we were actually checking some monitoring equipment.
Okay.
So yes, the seismometers went off telling us that it was about to go. Thankfully, it was a minor eruption, so we were completely safe. But it was snowing ash down on us as we were getting out of the vans.
Oh, wow. Wow. Okay. So raining ash. Wow. Okay. So we have a couple of questions. Brianna, if I'm saying your name correctly, it says, do you just look at Venus or do you look at a bunch of different planets?
Yeah, so the two planets I study most right now are volcanoes on Mars and volcanoes on Venus. But I've also done some work on volcanoes on the Earth, and a little bit of work on the Moon as well.
Okay. How many planets actually have volcanoes? And that came from Becky.
Yeah, so we've seen volcanoes on the Earth, Moon, Mars, Venus, Mercury now as well.
Oh, wow.
And then the Moon Io as well. However, only Io and the Earth and possibly Venus have active volcanoes that we've seen. So we've seen active volcanoes on Io, we've seen active volcanoes on the Earth. We think we've seen active volcanoes on Venus now as well.
It says, what does the yeast represent in the actual volcanic reaction?
The yeast just makes the reaction go. It doesn't
Says the
actually
panelist.
represent anything physical in a true volcanic eruption. It's just sort of what sets our reaction going.
Do you know about what's the average height of a pancake dome volcano?
They are 1/2 to 1 kilometer.
Okay. And Justin, going back to knowing more about you, what is your job actually called? What is your official title?
I'm a senior staff scientist. I'm a geologist, a planetary geologist.
And what kind of volcanoes can you describe for us on Earth?
The Earth has lots of different types of volcanoes. So Hawaii are typical shield volcanoes, where magma is just coming up from underneath the crust and making a volcano. We have volcanoes where two plates are colliding, like the west coast of the United States and Mount St. Helens, and the volcano I was on, Popocatépetl. We also have volcanoes where plates are pulling apart. So in the middle of the oceans, in the middle of continents, where we have got volcanoes there as well. And then we have got all sorts of sort of spatter cones and things where magma interacts with ice and magma interacts with water, making different volcanic structures. So there's lots of different types of volcanoes on Earth.
Okay.
We're almost out of time, so got several more questions, but we're almost out of time.
We want to know, what's your favorite planet?
Oh, probably Mars, but Venus is definitely catching up with the more I study it.
Okay. And I think that this question goes, how is basalt formed?
There's different types of ways that we can form basalts. So that's a magma that comes out of the interior, like at Hawaii. It happens when the interior of the Earth gets too hot and it melts part of the interior, and that magma then comes up to the surface. So it's the interior of our planet releasing its heat.
All right. We're going to take one more question, and I'm going to give this one to, how hot are the volcanoes on Venus?
We have no idea.
Okay.
We don't have enough data at this point to actually measure the temperature of these volcanoes. That would be a wonderful, amazing thing to do, and hopefully we can get there either in my career or in all of y'all's career. But we're not there yet with the technology to do that.